Okay, so the second part talks about being able to prove when four coordinate points are given, when a quadrilateral is given, and you have to conclude based on the diagonals if this quadrilateral is just a rhombus, a rectangle, or if it's a square. Okay, so we need to be able to understand first what is given on the square, on this, table of information. And here it says, if the diagonals are congruent, let me use another color. If diagonals are congruent, see, this is diagonals right here, okay? If the diagonals are congruent, then the parallelogram is going to be a rectangle. If the diagonals are perpendicular, then the parallelogram is going to be a rhombus. If it's both congruent and perpendicular, then it's going to be a square. If you look at the example, on the example, diagonals, well, it would be these two vertices make one diagonal, and then those two vertices make the second diagonal. As you get the distance between AC, that is square root of 41, the distance between BD, that would be square root of 41. So diagonals are congruent, therefore it would be a rectangle. Okay? Now, on the second one, if you look at the example at the bottom, it says, if the slopes, look at the slope. The first slope is 4 over 5. The second slope is negative 4 over 5. Are those two slopes are perpendicular lines? What do you think?
Don't this be negative reciprocal?
It would be negative reciprocal. That is right. So are those two reciprocal slopes?
No.
No. Right, Quentin?
Yes.
Okay. So how can we make these two to be negative reciprocals? One is 4/5, the other one is negative 4/5.
Well, you can make it negative 5/4.
I need to make, one of them like negative 5/4. Or I can just make the 4/5 into just 5 over 4, right? So are these two diagonals perpendiculars? No, right? Because since they're not negative reciprocals, or the product of that is not equal to -1, then the diagonals are not going to be perpendicular. Therefore, it's not a rhombus and it cannot be a square. Okay, so now let's go ahead and try number 5. So for this problem, get a blank sheet of paper, please. Let's get a blank sheet of paper.
Paper?
Yes, let's get a blank sheet of paper. And then we're going to go ahead and get the distance. We're going to get distance of Vx and the distance of Wy. So help me out on getting the distance of Vx. So that should be the square root of what?
What?
What should I put first on the distance formula?
11 minus 3.
11, okay, so 11 minus 3 quantity square plus what?
Plus 4 minus 0.
4 minus 0, and then it's quantity square. Then we simplify that. 11 minus 3 would be 8 square,
Yes.
and then it's just 4 square, so 8 square is 64,
Yes.
and 4 square is 16, so 64 plus 16, that would be 80. But then 80, we can simplify that with the perfect square root numbers, 1, 4, 9, 16. What number goes into 85? 9
No,
it
7.
doesn't go evenly.
8.
There's no 8 on the perfect square root
Oh, no,
numbers.
64, 60.
64 doesn't go evenly.
I'm thinking something else. My bad.
So use it.
No. 16.
16 is the number. So 16 times what?
16. Why don't I just use my calculator?
Good idea.
80 divided by 6.
5, that is right. 16 times 5, so therefore square root of 16 is 4. So the distance is 4 square root of 5.
My head hurts.
Okay, so we got the distance of Vx. So the distance of Vx is 4 square root of 5. Now let's get the distance of Wy. So 8 minus what? Minus 6, quantity square plus what? 0 minus 4, quantity square. Okay, so 8 minus 6 is
It's not 2.
2, and that would be square, and this is going to be negative 4 square. When you simplify that, what is 2 square? That would be
4 plus 6
4
plus 16.
plus 16 is square root of 20, and 20 is the same thing as square root of 4 times square root of 5, and that would be
2 over 5.
2 square root of 5. So the distance from WY to Y is 2 square root of 5, and then from V to X is 4 square root of 5. So what can you say about the distances? If they're different, then is that going to be a rectangle? No. So this is not a rectangle, okay? So here, not a rectangle. Okay, so if it's not a rectangle, then what else? Well, now you need to get the slopes, okay, to see if the diagonals are perpendicular, so we can say that it's a rhombus. So the slope of Vx and then the slope of Wy. Okay, so let's get the slope of Vx. So the difference of y's, what do you want to put first?
Difference in y, so it's 4 minus 0.
4 minus 0 over the difference of x's, which is
11 minus
11 minus 3.
Yes.
So that would be 4 over 8, which is 1 half. And for Wy, that would be 0 minus 4 over
8 minus 6.
8 minus 6. And then we simplify, that would be negative 4 over 2. When you simplify those numbers, that would be
2 over 1.
negative 2 over 1. Look at the slopes. Are there negative reciprocal slopes?
Yes.
Yes. So therefore, here we can say that a parallelogram V W X Y is a what?
Is a rhombus.
It's a rhombus. Period. And that's the conclusion. Okay? Any questions on how to determine if the parallelogram it's a square, rectangle, or rhombus?
So the slopes are
Either negative reciprocals, then it's going to be a rhombus, yes, okay? Now let's do one more. Let's do problem number 6. Go ahead and try number 6. Let's try that.
By yourself?
Would be a good idea. Tell if it's a square, a rhombus, or a rectangle. Well, when you get the distances, and you get the same distances, like in this case, it's the square root of 26 and the square root of 26. If distances are the same, that means that diagonals are congruent. Therefore, it's a rectangle. Okay? Then when you get the slopes, and with the slopes, if the slopes are negative reciprocal slopes, which in this case is 1/5 and negative 5 over 1, then the conclusion is that the parallelogram, it's a rhombus. And if it's both rectangle and rhombus, then you can make the conclusion that it's a square.
And when it's only the slope that's the same.
That is right. If this is the only thing that is true, then it's just a rhombus. If this is the only thing that is true, the distances are congruent, then it's just a rectangle. Yes, okay? Any questions about 5 or 6?
Well, I actually had a question about the back. There's a
Okay?
you put a problem that's currently not a theorem. How does it apply?
There's a
Like
problem.
number 3.
Number 3. Okay, let's take a look at number 3. If a parallelogram is both a, is that what you're talking about?
Yeah, because this exercise 3 is not saved as a theorem. What
Then it's a square. So what is that supposed to be?
Like, is it both a rhombus and a rectangle?
No, it's both a rhombus and a rectangle. You're right, yes.
Oh.
Yes, yes, yes.
Oh. I
That's all
didn't-
you have to say, number 3.
Oh, okay.
It's got to be both in order for the parallelogram to be a square. Good
It's
point.
because it sounded confusing. I would never anticipate it's both a rhombus and a rectangle.
And
I would
yeah.
say like it's both, has both properties.
It's
with it.
both a rectangle and a rhombus, yes. Okay, so then if you do number 7 and you complete number 7 before you guys leave, or by the end of the day, bring it out, stamp it, and you get 10 extra points.
Just 7?
Okay, just number 7. The whole thing is for homework. The back side is all for homework. But if you only have 7 by the end of the day or by the end of the period, show me that and I'll stamp your paper. Okay?
Oh,
Any
the 7?
questions?
The 7? or
Number
9?
7 on the bottom of the homework.
Okay.
That way you get that taken care of. Okay?
Are you done for the day?
Yes.